Hey guys, I'm Blake, and today I'm going to show you how to write a website front end in COBOL. Yes, you heard that right. The 1960s programming language developed for business professionals you usually find on mainframes. So, first let's set up our environment. Alright, so now we're going to log into the mainframe. We're going to do our web development on. So, there are many paths to write a web app or a website front end in COBOL, but today I'm going to show you the way I felt was most obvious. To do that, we're going to use the GNU COBOL compiler, which on the back end transpiles our COBOL source into C source before then compiling the C source into your target. We're going to just skip that last section and then have our COBOL transpiled into C. Then we're going to use our mscript and SDK to compile our C source into WebAssembly while also providing some standard libraries. If you don't want to set up the environment manually, I have a container pre-made on GitHub. Here, I'll link this in the video. But otherwise, I'm going to show you guys how to set it up manually for those interested. To start with, we're going to need GNU COBOL and the mscript and SDK that is installed natively. I already have those both installed here, we can see. Beyond that, we're going to need the GNU COBOL library in our web environment to execute our transpiled C from COBOL. The only dependency that GNU COBOL's library needs beyond the standard libraries provided by mscripten is GMP. I already have GMP and GNU COBOL downloaded and ready to build. You can get those both at their respective websites. We have GNU COBOL's SourceForge area where you can get the native binary and also the source. Same goes for GMP, and then mscripten has a nice install script for you as well. But we're going to build those. We'll start with GMP since GNU COBOL libcob depends on it. To build this library is going to be the same pretty much as you would standardly, except for we're going to run it through mscripten's versions of the tools to configure and build it properly. For GMT I make a build directory just to make this easier. So first we're going to call emconfigure on our configure script from the other directory. But we want to specify this host none, since the configure doesn't have a default host for WebAssembly or an mscripten or any of that kind of stuff. So That's why we pass this in here. This will configure our build just like any other. But in this case, they'll be targeted at WebAssembly. Okay, now we build it as per usual, but we pass it through Emscripten's make helper. This basically sets its environment as it's running, and just to make sure that it's building for the proper target with the proper flags. Alright, looks like we've successfully built our GMP library. So now we're gonna have to copy it over to our Emscripten SDK so it's easier to build with. So basically we need to get our header files into our include directory that Emscripten's SDK uses by default. We could pass these as compiler flags and all kinds of things, but this just makes it a lot easier. We're basically installing this library to Emscripten SDK. The path for your Emscripten SDK and its include directory would go here. In my case, it is this. That's copied our header files over. Now we want to copy our libraries over. When it builds into a hidden directory here. And this will be our library directory. And now we have GMP built and installed in our Emscripten SDK, essentially. This means we can build with it and link it. That means we're ready to go on to GNU COBOL. For GNU COBOL, it's again almost the same process. with just some minor caveats. We only need to build the GNU COBOL libcob, the library for it. So that's one aspect. We don't want to build the whole tool chain. But we have to configure it from this base directory. So just like last time, but from this base directory, we'll run emconfigure. Oh, I did miss one thing though, you guys probably noticed. I'll have to get this to stop real quick. I actually missed two things. We're going to build the libcob library without DB, without the database section. This just makes our build easier, we need less, and it'll work properly inside our web environment. I'm sure there's a way to build it with that, but I haven't. And then we also have to define our host as none, just like last time, otherwise we're going to get some weird targeting issues. Alright, we're configured. Now we can build our library. Since we're only building the library, we're going to change directory into libcob. And from here is where we're going to run our makefile, our build script. Perfect, so we've built our libcob library targeted at WebAssembly. Now we just want to practically install it in our EMSDK. To do that, it's going to be very similar to last time. First of all, we want to copy our headers over from the base directory as well as the libcob directory. So whoops. Then we want to copy over any headers and libraries from our libcob library, which is going to be the same. So we can just go back up to here, copy over our headers, copy over our definitions in this case too. And then we're going to copy over our actual libraries. It's worth noting we need to maintain this structure, so I actually messed up here. we're going to have to, I think I've already created the directory, but we're going to have to actually copy over our headers and such from this libcob directory to our libcob directory in our mscript and SDK. So you don't have that folder in the SDK, which you won't. You'll have to create that directory at the include folder. Let me redo that then. Now we've actually copied our libcob headers over to the proper area. Same with our definitions. Since we didn't overwrite anything in my last two, it won't cause any errors. Now we can copy over our libraries. For our libraries, we don't have to maintain the libcob file folder or directory structure, since they're all referenced from the same location. The actual libraries themselves are what's going to be trying to locate headers in a specific directory orientation. But now we have actually successfully built and installed our libcob library. Now for building with mscripten, we can use GMP or libcob, meaning we're at the point where if we want to, we can compile our COBOL into our web environment through this toolchain we've set up. The problem here is it's not very useful without being able to interact with our web environment. To interact with our web environment, we're going to need some more stuff. We're going to need specifically some sort of wrapper library to communicate with, say, the HTML DOM or some sort of JavaScript, whatever you may have. For this, I have also created a wrapper library on GitHub. I will link, known as COBDominate. Thought it was a fun name. It's pretty basic, but it allows for fetching cookies, interacting with the HTML DOM, all kinds of stuff, and it definitely has the basics required to make a website front end in COBOL. I'm not going to show you guys entirely, we're not going to build that from the ground up, but I will show you sort of what it looks like and the idea behind it. To write a wrapper library, you can use almost any language you can get to communicate and interface with C, or whatever you're using. In our case, though, we are kind of using our base of C. So you could write this in COBOL. You could write a wrapper library in COBOL, and that would be fine. Or you could write it in JavaScript. In our case here, you could write it in all kinds of stuff, but I chose to write it in C. I made a demo, or I started, I suppose, writing it in COBOL, kind of as a proof of concept. We'll pull that up here just to show you. Alright, whoops. It looks, it's kind of, I mean, we're abusing COBOL here for all of this, clearly, right? Most people don't write their websites in COBOL, but the same could be said for wrapper libraries, especially when you're interfacing with C and JavaScript and all kinds of stuff. So, kind of abusing it. The C version that I have is a lot better. You can check out the source on the GitHub, but it's pretty simple stuff. So now that you have some sort of wrapper library, all you need to do is build and install it for our mscripten SDK. In the case of this library, I've made a makefile to make this easier. If you do use this library, all you have to do is make sure that the install directory points to your mscripten SDK properly. But now we have a full build environment and toolchain set up to build COBOL web apps and interact with the web environment. So we're ready to write our first Hello World program. If you want to look at a slightly more extensive version of this, I have a example on GitHub too. I plan to update this because there's a lot that isn't also in this example, but you can play around with this. I'll link it as well. For today, I'm going to show you how to actually write a Hello World from kind of the ground up. For this, I've created a few simple files here. We got our main program, which is your standard free format COBOL program. I have quite a few divisions and sections and such in here that we don't even need, but I just thought were funny, like object computer wasm. Figured if someone goes back and reads this and sees that it's targeting WebAssembly, they'd be really confused. Beyond that, it's all pretty standard, but you'll notice in my procedure division, I don't just jump into code. I've defined a main section and entry point. This gives me some more control later in the execution cycle of our program. It helped me prevent some errors I was getting in some bigger projects. Beyond that, we got our 3 calls here, which are interfacing with our wrapper library. It's just used to create an element, set its inner HTML to hello world, and append it to our body in this case. Pretty standard stuff. And then I have this display down here with hello world to kind of show some of the quirks of our environment as well as far as standard in and standard out goes. Next we have our index host file, since we're going to be running this in a browser. It's very simple, could be even simpler probably, but we just source our main.js, which is a companion file generated by mscripten when we compile our WebAssembly. It's going to just effectively link our WebAssembly. And this is what I was mentioning with that control earlier. This allows me to wait until our mscripten module is initialized and then manually initialize our COBOL and then call our main function in order, or procedure that is. This ensures that everything's run in the right order and set up. That's it for our source. Now we can check out this main makefile, which we're going to build this all manually, but this is kind of going to give us a base to go off of and explain some things. We have some niceties up here for our source directory and build directory, but then you'll notice this cob export flags variable. This is used in COBC to force some static entry call generation. Without this, we get errors with undefined functions and procedures and such. So what we got to put in here is any sort of function we use from our wrapper library. In this case, I have all of the available functions from the last build of that wrapper library. This just eases development. Since we have them already, we can use them. We don't have to come back in here and append them. Beyond that, you also have to pass in any sort of procedures you define in your COBOL, or entries you define in your COBOL program, that is, that are going to be called externally, even if that's indirectly, right? So if you, in your COBOL program, say, set a timeout to call another procedure in that same COBOL program, you need to export that entry point here so it's accessible to that timeout. Beyond that, it's your standard makefile, but we can get into the quirks of mscripten down here as well. Before that, though, let's see this COBOL transpile. We have COBC -free to define that it's free format, -C to define that we only want the transpiled C. Our output, our source, and then you'll see we have that variable from above getting all of our export flags. Next, for our mscript compile, which are pretty standard stuff as far as including our libraries, but we got to make sure we export certain functions and runtime methods. For our exported functions, we need to export malloc and free used by our wrapper library, and then cob init for our libcob and our main entry point for our own COBOL program. For our runtime methods, we have to export ccall, crap, and heap8, which are going to be used as well with our wrapper library from the mscript library. At the end here I have the suppressor. This is just some warnings generated by the COBC transpile. It all works fine, but it cleans everything up to have them suppressed. So now that we have all that, I'm going to show you guys how to build it all manually using the structure from above. So let's start with making our directory structure. We had a build directory, and inside that we had our web. I have it set up this way because we kind of build all the base in this build directory, but the stuff we're actually hosting I put in the web directory. So we don't need, our C files and everything in the web directory. We just need our WebAssembly and JavaScript. To start off, we transpile our C, just like above. I'm going to basically just copy that. We're going to output it into this directory as main.c. Our source is in the parent directory as source main.cob. And then we got to generate our static call entry points. We only used from our wrapper library create element, inner HTML, and append child. So in this case, that's all we need. As long as I typed everything correctly, this should build properly. It looks like it did. Let's see if we have all the files we expected to generate. We do. So now we're ready for our mscripted build. Just like above. Our source is the C we've just generated. We need our libraries. Our exported functions. You'll notice that for the exported functions you have to start with an underscore. And then for our exported runtime methods, same as above. And I'm going to leave off the suppressor to show you guys those warnings. But as long as I typed everything correctly, this should work. Looks like it did. Those are those warnings I was talking about. Let's see if it generated the files we expect. It did. So yeah, those warnings are just from the transpile, but that's what they look like. Now, we've successfully built our first Hello World COBOL web app. Let's check it out. Here it is. So we'll see we got that Hello World we expected on our page. And then we got our hello world and the console out. That's from that display I was talking about earlier. What's interesting about this, any STD out, any standard out you generate from this COBOL program will come out to the console, but no standard in will work. Any sort of standard in from COBOL will not work. So be wary of that. It's a quirk of MScript and really it's a complication of WebAssembly in general. You kind of need to like explicitly define how you're going to do standard in and standard out, and that can turn into a pretty complicated process with, you know, running it synchronously and preventing execution and all kinds of stuff. So that's how that works. But yeah, that's a hello world in COBOL for our web environment. Now I want to show you guys a few more fleshed out examples, extensive examples. For one, we're going to start off with kind of a proof of concept, possibly temporary. I rewrote my web portfolio in all COBOL, technically 99.25% as of the last build actually, but yeah, it's a good example website showing some of the wrapper library. We have working cookies here. In this case I have a language selector. We get dynamic updates for everything. It's kind of fun. All of these links work. I got a nice little SVG here, some SVGs there, special fonts, all kinds of fun things. Then you'll see I got this little menu selector. All these link to auto scroll. But yeah, that's kind of a fun, pretty realistic example. And then I got kind of a more abstract example, but showing more dynamic stuff you can do with this. So this, you'll see this web page has a specific layout for a specific ratio. That is width to height ratio. In the case that it meets this requirement, we have the kind of main area rendered here, and then these two areas stacked and put on the side of that main area. But if we change orientation or resize to something a little bit too narrow, it'll render these two areas side by side stacked on top of this main area. And this is all done in COBOL. So that's kind of fun and shows another more dynamic use of all of this. Beyond that, it's essentially your dream. Whatever you want to do in your web app, you can do with COBOL now. So that's that. That's how you write a web app or website front end in COBOL. Thank you guys so much for watching.